Hi, I'm Ms. Fung. Let's have a look at independent events. So for example, if I toss a coin and let's say we have heads, and then I went and toss again, what are the chances of getting head? It doesn't matter, right? It's still a half. So we say these two events are independent. So what's the probability of getting heads on the second toss given the first toss is head? Well, we could actually use a formula from Pr7 where we find the intersection over the second thing in the bracket, which is tossing the first coin as head. So let's see what happens when we use a formula. So the intersection of the second coin being heads and the first coin being heads, so heads, heads, we know the probability of heads, head is a quarter, over the probability of obtaining the first one as a head. So one toss, one head is a half. A quarter over a half is just a half, what we expected, because the probability of getting heads is independent of what happens previously, which is the same probability, a half. So in other words, a way to explain this is the probability of tossing a head in the second turn, given that the first turn is head, is just the same as probability of tossing the head second turn. So probability of A given B is just probability of A. That B doesn't affect it at all. So what can we do with that? Well, if probability of A given B is A, we say that they're independent. And when we had the formula before, remember the multiplication formula? And if A given B is just A, then we now have A times B is equal to the intersection. So when we have independent event, A times B equals intersection, because A given B is just A. And we can say the opposite too, that B given A is just B, so the same pattern occurs. So probability of, remember the addition rule brief in a few videos ago, that the addition rule, when you're mutually exclusive, then A plus B is A union B. Now if you're independent, A times B is the intersect. Oops, let me go back. So recap, when the addition rule, if you're mutually exclusive, then A plus B is the union. And if you're independent, A times B is the intersect. We're going to use this to check whether things are mutually exclusive or independent. So before with the coin toss, we can see that the intersect of a quarter tossing heads twice is the same as tossing the first time heads, a half, and tossing the second time heads, a half times a half is a quarter. They were independent events. So we're going to use this line to test, are you independent? And we're going to use this line to test, are you mutually exclusive? Let's have a look. Okay, let's test if they are mutually exclusive or they're independent. So if that's true, then it's going to be mutually exclusive. And if that's true, then they're independent. First of all, let's look at the probabilities of A and B in these three examples. So we have 5 out of 10 for A, so a half, and 5 out of 10 for B, so a half. Here we have 3 out of just 9, so a third for A, and here we have 4 out of 9 for B. Here we have 2 out of the 10, or a fifth for A, and we have 5 out of 10, or a half for B. So I'm giving you these three examples because the answers are going to be slightly different, and we will see how we say whether they're independent or mutually exclusive. So let's do the independent test first. So we multiply the half by the half, and we see if we can see that it's equal to a quarter, and we ask, is it the same as the intersect? No, the intersect is 0. So if that fails, then it's not independent. And not independent means dependent. It's confusing because it's a double negative. Let me say it again. Not independent, so dependent. So this one, a third times 4 over 9, so the independence test. So when we multiply, we get 4 over 27. Is the intersect 4 over 27? No, it's not. So again, we failed the test. So we are not independent, or in other words, we are dependent. And then last one, a fifth times a half, we get 1 over 10. Is that the intersect? The intersect is one thing there out of 10. So yes, it passes the test. So this example here, this Venn diagram is independent. So when it fails, it's not independent, so it's dependent. When it passes, it is independent. bit tricky. So you might want to watch that bit again. Now let's test if they're mutually exclusive. So here we can see that it's mutually exclusive, but let's do the test. A half plus a half, is it equal to the union? The union we can see is 10 out of 10, or in other words 1. So it is equal to the union, so they are mutually exclusive because it passes the test. Here we have a third plus 4 over 9, which gives us 7 over 9. Is 7 over 9 the union? The union is 1, 2, 3, 4, 5 out of 9. So it's not equal to the union, so it's not mutually exclusive. Over here we have a fifth plus a half, which gives us 7 over 10. Is the union 7 over 10? 1, 2, 3, 4, 5, 6. It's only 6 over 10, so it's not the same as a union. So it's not mutually exclusive. This one's a little bit easier to see because you can actually see that there's a disjoint there, so they're mutually exclusive. And here they don't have a disjoint, so they're not mutually exclusive. But I wanted you to see that the test works. So if you add them and you get the union, then you're mutually exclusive. If you multiply them and you get the intersect, then you're independent. And this is how you show whether something is independent or mutually exclusive, by doing the test. Multiply, get the intersect to be the same, independent. Added to be the same as union, mutually exclusive. Note that if you're mutually exclusive, can only be independent if A or B is 0. So whenever you're mutually exclusive, you're more likely to be dependent. Let's do a question. An analysis of traffic accidents in a certain city classified the accident as serious or minor, as well as if the driver was speeding or not. So here we have the table. So speeding, was he speeding, yes or not, and whether it was serious or minor accident. Is the seriousness of the accident independent, so seriousness, independent of whether the driver was speeding or not? And speeding, independent, is serious, and speeding, independent. So what do? We find out the intersection of speeding and serious, which is 42 out of the total, 42 out of 376. And then we do the multiplication rule and see if it's the same. So the serious is 103 and the speeding is 130. When we multiply, we don't get the same as the intersect. So recap, it's asking if it's independent. So we look at the serious and speeding, we multiply them and we check if it's the same as the intersect. And it's not, so we say that it is not independent, or in other words, it is dependent. What about this one? A die is thrown and the number uppermost is recorded. Events A and B as defined as even number or square number. Show that A and B are independent. So we need to show that A times B gives me the intersect. So let's figure out what A and B are. So A is even, so that's 2, 4, 6, and B is square. There's only 1 and 4 are square numbers. So what is the intersect? The intersect is just a 4, so one number. And now we do the probability. Probability of A is 3 out of 6, which is a half. B is 2 over 6, which is a third. And intersect is 1 out of 6. So now we do the multiplication. A times B gives us a 6. So they are passing this, or in other words, yes, they are independent. Okay, that's it from me today. Have a look at the videos again and thank you for watching. I'll see you next time. Bye.